I see that most of you have the handout downloaded, and also in that handout is the attendance link and the feedback link that you will use at the end of the session. We are about to start. Okay, so today we're going to talk about next generation learning standards in mathematics, grades 6, 7, and 8. And you say, wait a minute, we already had that like several times. Well, today is a refresher. And you say, how can we put another piece in? Well, we have looked at curriculum, alignment, pacing, and next gen before. It's not a new piece. It's really bridging that gap and putting it all together for grades 6th, 7th, and 8th grade. So you've downloaded the handout and also completed the attendance, or you are completing the attendance. And at the end of the session, you will find the link for the feedback at the end of your handout. So along with that refresher, because we are very aware, our grade 6 and 7 teachers have just been through state testing. That state test aligned to next gen. I know you are very familiar. So today, deep understanding or deepen that understanding. From there, implications on instruction with support and resources, which I always call project learning. The more we have, the more we will learn. All right, and so now we will see what we already know. Since it is an activity that revives or deepens our understanding, show me what you know about next generation learning standards in this Mentimeter. Okay, I see you're feeling it out. We're pretty sure about it. We're aligned. We're comfortable, easy, ample, proficient even. I love that. You like them. Me too. Confident and developing the new strategies. Excellent. I love what you're learning about these and what you have learned and going to demonstrate today. So with that, let's move forward. Today, actually, this year, right here, we have been implementing grades 3, 8, the implementation of the next generation learning standards in mathematics with the test changes in that area. So our grade levels or grade band that we're talking to today, you are very aware because you've had to focus on it. Now, let's just glance very quickly as to what is coming forward. In June, after actually 23, 24 and on, it's our grades 9 through 12. Here we'll make sure that the implementation of next gen is also in algebra, also in geometry, also in algebra 2. And with that parallel, the regents will also change. And so that is where we are and where we're going with this. So let's have a flashback. All right. The first thing we learned, I think, June of 21, after COVID, we learned about the shifts and we talked about what was going on with the shifts in next generation learning standards and how does that apply to each grade band. Well, in 6th grade, just the highlights, no standards moved. And you got 7 new ones. Yes, 7 new ones came in statistics and probability from the 7th grade. In fact, a lot of the probability, in fact, all of the probability, except you'll see compound probability stayed within 7th grade. Also, you inherited a geometry standard for area and volume of cubes. So that's what happened in 6th grade, and is also reflective in the state exam. In 7th grade, you inherited the box plot or box and whisker. And I've seen this being taught. This is the time we usually teach that. I've only seen horizontal box and whiskers. I just want to remind you, those guys get vertical as well. And also you kept compound probability. So I've talked to some 7th graders say, oh yeah, the 7th grade teachers, that all went down to 6th grade. Well, almost all. You house and you have compound probability. you also currently have 7th graders that did not learn it in 6th grade. Oh, yeah, because the shift happened when it was implemented this school year. So you might have to teach simple probability to get your students to understand compound probability. In 8th grade, it was one of the heavy hit grades with Common Core. 5th, 8th, and Algebra 2, heavy hit with more standards than they had back in the standards and framework days. And so there was nothing new in 8th grade. And luckily, two-way frequencies went back up to algebra where they belong, where they sit with the contextual part of table frequencies and calculating those. And so I also included the link. If you need the link to find the more than the shifts and the snapshots, then I put the link, and it's also in your handout for the snapshot and the crosswalk. So where did I get that information? I just gave you the highlights from, and let's look at 6th, because in 6th grade, you see all these new guys here and nothing moves. So that's where I highlighted that. We also are about to talk about some of the language that changed, really some cool stuff. And I think that's what our teacher that put in the Mentimeter a while ago said, oh yeah, I like it. It's good. It really is good. They're easier to understand. So moving forward and talking about that language, you notice that if you look at the standards in the Next Gen, not the crosswalk, but actual standards, you're going to see things like the EG, for example, and you'll also see note. That's what most teachers really love. There was a lot of interpretation going on back in 2011 and the decade after that, we just had a standard, and it's like, oh, I wonder what problem those are talking about. Now there's no guesswork with Next Generation Learning Standards Mathematics. It gives you the EG, for example, gives you a sample problem that aligns with what the standard is talking about. No guesswork, no interpretation. Wonderful. Another thing that I like in thinking and planning for instruction, it gives me this word right here, expectations. So with expectations, I know the highest level of mastery of what students are expected to do. I mean, if I shoot low, guess what they're going to, no, we won't go there. Yeah. All right. So gives me the level of expectations. They need to know unit rates, and it's not limited, or they are limited to non-complex fractions. Oh, good to know, right? All right. So then here's an example of 7th grade. I chose EE because there's a lot of interpretation going on here as well. Choosing those EE problems, just because I choose an equation or an expression problem doesn't necessarily I have met 4A, point 4A. What does that mean? All of this, compare an algebraic solution to arithmetic solution. What does that look like? Simplistically looking at a problem, look at this. Perimeter of a rectangle, 54 centimeters, length of 6 centimeters, what is width? Boom. All right, so that's what that means? Yes, that's exactly what that means. And what's my note? Oh my goodness, look at the last sentence. This standard is a fluency expectation for grade 7. And you go, hold on a minute. Fluency stops at 5th grade. True. You left out the word operational. Operational fluency, we stopped teaching after 5th grade. However, we still have expression, equation, formula. You got that. All right. So there's other types of fluencies that we start with the 6th grade going through Algebra 2. So we become fluent in an algebraic sense. So this lets me know expectation, and then it's also a standard in fluency. I love that. 8th grade, so here we go here. Solving systems of equations. What does it look like? And it tells me about the solutions. and it uses words like simultaneously. And so we know that we're looking at all the outcomes with systems in the 3 types of outcomes. And it also lets me know, okay, it will be limited to at least one equation containing at least one variable whose coefficient is 1. All right, so we don't really explode it so much in 8th grade. It explodes in Algebra 1. It really explodes in Algebra 2. Look at this. This also is a standard, is a fluency expectation for 8th grade. So you see, we really dig deep, a deepening of understanding, noticing the differences of writing from Common Core and the simplistic language, the extra language that they give us, that what informs us about instruction. So here we go, check, check. We have started our refresher. We know how to deepen our understanding, the notes and examples. But you know what? The implementation of the next generation learning standards doesn't happen when we just read them or talk about them. It doesn't happen until we implement in instruction. Actually, nothing happens until instruction and learning start to go into the classroom. It doesn't matter how we plan. It doesn't matter, what type of assessments we get. The implementation of next generation learning standards happens through effective instruction. And that's what we're going to talk about. And of course, the resources, what I call project learning. So I really thought about what are some big ideas of instruction and the standards. Of course, discourse, problem solving, scaffolding, and differentiation. So discourse, you go, oh, we do that. We discuss, we collaborate. Okay, good, great, great. But discourse also deepens the discussion, the conceptual discussion in mathematics. Discourse is where the word justify gives birth. So to explain is a discussion. Okay, I multiplied, I divided, I simplified, and the solution is. The procedure used was. That's discussion. Discourse is where we start to really think about the word justification. I want you to think about justification in the courtroom context. Justification is not about proving your innocence, not about explaining yourself, not about discussing it. It's about justifying why you are not guilty. That not. The negative aspect, the area where that's not the answer. That's how we justify our solution. It's this, and it is not A, C, or D. It's B because when I tried A, C, or D. All right, so that's where we're going, and that's why we use the word discourse. It is very different. It is a deep understanding where we actually use discrepant events to show why ours is correct and this is not correct. So that is a big point in what happened with problem solving and the math talk in your classroom. So I know I spent a little bit of time on discourse, but that's one of the true hearts of problem solving, and problem solving is the heart of mathematics. You say, well, we don't problem. Yeah, we do. We problem solve in kindergarten. We problem solve in calculus. And guess what we do every day in life? Oh, yeah. Tell me you don't have any problems. No, don't tell me about your problems. Okay, exactly. Every time we come into a problem in real life, and that's what we try to grow reasoning and logic with our students, we are using discourse. We're not explaining ourselves. Discourse means I have a flat tire. So what do? You start to Google and you read blogs, and is this a good store? Is this too expensive? A, is not right. It's too expensive. B, oh, they don't have the size I need. You see where I'm going with this? Problem solving that we use as adults includes discourse, includes justification, includes reasoning and logic. We have to, reasoning and logic can be taught, critical thinking can be taught, discourse can be taught. And through the umbrella, or through the foundation actually, of problem solving. So that's where we're going to spend our time talking about instruction, instructional design, and where the next generation's standards live, that comes to life through really rigorous instruction. Rigorous instruction in mathematics is the act of problem solving. Then scaffolding and differentiation. Don't read ahead, but just ask yourself, do you know the difference? Did you know me included? We use those words all the time, sometimes correctly, sometimes incorrectly, and sometimes so blended that we can't tell the difference. There are actually lots of articles. Google it, not right now, later, and say scaffolding versus differentiation. Today we'll clarify, and we'll still be like, is that scaffolding or is that differentiation? But we also need that to build successful problem solvers, to build successful mathematicians. So here we go. Let's math talk, shall we? All right, put in the chat which one does not belong. Notice not guilty, not belong. You know where I'm going then. Oh, it's because you guys are great mathematicians. Students might be distracted by what? Right, the shaded triangle. We as mathematicians looked at the attributes of the shapes. The attributes of the shapes are what? Three are triangles by definition. All right, three angles, three sides. Here we go. One's isosceles, one's right, one's scalene. We didn't have to go there, but we did. And the hexagon does not belong. We would be distracted if we thought shading was a vocabulary word that we're supposed to, yeah, fractions were shaded, but was fractions the act of the concept of you see? All right, let's go. All right, numbers. Because you're good mathematicians, perfect squares, and one is prime. Excellent. You guys are great. But give this to your students. They might even take, 42 seconds to do this. So if I were going to teach prime, or if I were going to teach perfect squares, this is how I would justify what a perfect square is. You see where this is coming from? That's cool, isn't it? You just have to do it. All right, 8th grade. My 8th grade teachers are already there. Excellent. I know you've been teaching slope. All right. So yeah, the negative 2x is a plus 4 is a negative slope. That is only a negative y-intercept. It still has positive slope, positive slope, positive slope. You guys got this. But what a great way to have students analyze the equation while you're teaching slope, to justify how 3 are like slopes and 1 is different. 1 does not belong. You guys are great. All right, so if you like this, it's a way to build mathematical vocabulary, mathematical discourse, and actually have or create a viable argument, which is justification. We use the word viable argument in the mathematical practices, those 8 instructional practices, and we use justify in our language in the rubrics for constructive response. So they are exactly the same. And so we are creating an experience in instruction where a viable argument will take place. And also we have allowed students through that experience, that creation or design, to justify and use that discourse in their language. All right, so all are part of the NGLS standards for mathematics. This site actually gave birth through some Charlotte Danielson work. It's a really cool site. I used one shape. I used one, you have to scroll down to see them. All right, so, and I used one of the numbers. I used perfect squares because you guys are 6, 7, and 8. All right, and also graphs. And there's also incomplete sets. They're really cool. And you see some of the graphs really extend into the upper level functions. Really cool stuff. All right. I want you to have all the resources that you need to create the instruction to clearly implement what's going on in your classroom with the next generation learning standards. Don't let it be a dead document. Make it be living instruction and learning. All right, so our math vocabulary for NGLS, just as it is in ELA, should be taught in context, in contextual learning. We should use word walls. We know our ELA brothers and sisters use word walls. We should do it too. We are teaching a language, not only just an English language, we're teaching a symbolic language. Mathematics has two things. We have a symbol, whether it's an X for a variable or an X that used to mean multiply. So we have symbolic symbols that can mean more than one function. And so we need to know that. And so word walls and active engagement in contextual learning helps us learn that. Math talks, like we just did, a little bit different than a number talk in the kinder, first grade, second grade. I even do number talks in third and fourth. Very different from that. That's really focusing on becoming operational fluent. And so the math talks is more about creating critical thinking, reasoning, logic, and that discourse in the classroom. And I know you've seen this before, but I'm going to give you the link because these are all the words that are associated with the next generation learning standards. Some of them we even pick up in kinder and first grade, like decompose and compose. Most of them belong to us. Maybe four through 8, they'll belong to us. And express, fluent, generate. Okay, you guys know this and you've seen them before. So I want you to have that, build that into your instruction experiences for your students. Now, some of my schools that worked with me for the last couple of years are smiling. 3 reads protocol. We cannot escape it. It is how we are going to move toward mathematical discourse through problem solving. It's how we develop that justification in our problem solving. So you say, well, 3 reads protocol, isn't that like for 3rd grade? Well, I put this up in the corner. In K5, we do read the problem 3 times. I do spend a lot of time working with the teacher, what questions to ask, how to respond to students, how to guide them through the process, what they are to do, what they are not to do. And so, and I put this thing, if you want to read it, in your handout. So yes, but we don't stop with operational fluency in 5th grade. They're going to bring the knowledge and skills with them. Okay, just say they do. And I want them to bring that knowledge and skill to problem solving. So they can read, or you can read, maybe 1, maybe twice, but always ask the 3 questions, like always. And I want them to start to get automated with asking the 3 questions. 1, the context of the problem. The context of the problem does this. It frames it. Before we read and find out the context of the problem, our mind is everywhere. Our mathematical mind is everywhere. But if I start to say, how will the Yankees win the World Series? Baseball, a team, 162 games, October. See what that did? Well, maybe not if you're a Mets fan. Just kidding. All right. So truly, what is the story about? What is the problem about? What is the context of the problem? Frame it, because that brings up a certain set of skills, a certain context of framework in mathematics in the neocortex. It brings out that memory and says, we're talking about baseball. We're talking about car racing. We're talking about buying groceries. You see the units change and actually the operations change and the equations change based on the context of the problem. That's why that question's so important. So we have to ask it. I want them to do it automatic. Frame it. Now the math information. All right. If we don't have the context, we say, oh, there are three numbers, I'll probably add. If we don't know the units, that could be three numbers, three different units, we would not add. All right. So you guys know this. Usually math teachers do this anyway. That's one thing that we have always done. What's the number information? What are the units? Boom. Go on to the third one. Now, this is where it gets loosey-goosey. I hear, no, what do we do? What are we going to multiply? No. This is not what operation to perform. In fact, I don't want operation mentioned because here's what happens. If we mention operation, I'm going to look over at, let's just say Jamie. Jamie, the brightest kid in the class, and she says to divide. Well, I'm a struggling learner. Guess what I'm going to do? Boom, I don't care about the problem anymore. I'm going to find the numbers and divide the best I can. Also, the problem might not be answered. A number will be come up with. Okay, it will be found, but we will not have answered the question. So please don't let your kids go there. And please don't let them shout that out and say, all right. The third question is, what is this problem asking us to find out? It's how we write the sentence. That's how we find the solution. We know what it's asking us to find out. I put down in some italics at the bottom. It's the third question that is the key to answering the problem or the constructed response. It's the place where the viable argument translates to our students being able to justify that solution, not just explain it. All right. Explaining is procedural. Procedural says, what operation did I do? You see that connection? Oh my goodness. That's so simplistic when we think about it. What's the problem asking me to find out? Viable argument. Justify. What operation do I do? Procedure. Explain. All right. I know I spent time on this, but it's that important. This is the heart. This is where it starts. If I don't have a contextual understanding of the problem, I can't frame it. If I don't have the math information with the units, I might choose the wrong operation. If I don't read the question, what is the problem asking me to find out, I go on a different angle. I do not go toward justification. Got it. All right. So if we had time and not 54 people, we would do this problem. Jody's car uses 12 gallons of gas to travel 456 miles. Got it. Frame. Units. Gallons, miles. Got it. It's not add. We're not even mentioning that, right? No. What is the problem asking me to find out? How many miles did her car travel per gallon of gas? There's several solutions we could have come up with without that little PER, per gallon of gas. Now, I know I'm messy, but I did it with my finger on the screen. So did I set up the equation? Did I use the units? Did I answer the question, 38 miles per gallon of gas? I did. Cool. Let's try it again. All right. Actually, that's a sixth grade constructive response from the state test. This is a seventh grade one. This is actually one of the most missed problems. I chose it for a reason. I wanted us to think about it, and I want us as teachers to think about, why did they miss it? If we use the three reads, why did they miss it? So Donaldson earns $18.80 per hour for the first 40 hours. Cool, got it. She earns 1.5. Okay, fractions. Fractions doesn't mean failing. All right, so fractions, they're fun. Earns 1.5 times that amount per hour for each hour beyond 40 hours in a week. Okay, that's got to be interpretive into a math sentence. That could be one reason. Finally, what is the question? Last week, Miss Donaldson worked 45.5 hours. How much money did she earn? All right, so you see how we could come up with a partial solution. You see how we could interpret the 1.5 incorrectly and do the whole thing. You see how we could say, oh, I've got it, but the 5.5, 45.5, that's another place for error. So it was too much for me to do on the screen with my finger. So I did this. So look at the interpretation of this. I did my units. First of all, I framed it. All right. I know it's about money. I know it's about working and getting paid. Adults know this. Kids don't, unless maybe they're high school kids. 18.80 an hour, 40 hours, and then the 1.5 per hour more, greater than 40. How many altogether? That's for the 40. And then I went over there and did, well, how much did she make? Isn't she? For 28/20s. And then I did that for the 5.5. And I could have stopped. Okay, but then I didn't answer the question. See, third question is cool. Then I said, then I answered it in the sentence. Miss Donaldson earned $907.10 for 45.5 hours of work. Did I answer it? Did I use my units? Did I interpret the problem? Did I frame it? Cool. 7th grade. They can do this. All right. Teach them how to dig deep in the problem using 3 reads. They need that. You owe them that. They need it. All right. So I know I gave you a clue. Scaffolding differentiations. Which one's which? Do we know? All right. So if this had been a real workshop, I'd make you go to a Padlet or talk to a neighbor, that kind of stuff. But it's just me and the screen. So here we go. So when you pre-read a learning objective before having the entire class read chorally or orally, you're scaffolding. All right, so you pre-read, then you have them do it. Scaffolding. Not just start with them reading. We got this. Scaffold. Now, what's differentiation then? Good grief. It's when an individual student cannot solve a problem and you rephrase your question from open-ended, from constructed response, to multiple choice, you differentiated. So are you kidding me? Yeah, that's how simple it is. And some of us might be aware if we use those terms regularly and we also plan instruction with those things in mind. But if we throw it around loosely, then we don't know if we're scaffolding or if we're differentiating. I just wanted you to be alerted. Okay, I am alerted that people do this with them all the time, especially mathematicians. It's like, yeah, scaffolded. No, you really differentiated. Well, who cares what's the difference? They learned it. Yeah. Well, in the planning for instruction, it's essential for us to know, does this student or this class need to scaffold the learning incremental steps so that the whole class gets a deeper understanding? Or do we have a set of struggling learners that we need to differentiate? Instead of making it open-ended or whatever, we give them a closed set, or we break it down. We use smaller numbers. A lot of times in mathematics, we can keep kids on grade level with a grade level problem, but the problem is not the conceptual skill. The problem is the numbers are big, or the numbers are, what they call them, broken. I just loved, I hadn't heard that in a long time. I heard it the other day. Fraction is a broken number. It's broken apart. It's like, okay, it's not really broken. It's just, okay, I got it. Fraction and decimal could be broken the way kids explained it to me. So we can still use the same skill, smaller numbers, whole numbers, right? So that is that is a skill in differentiation, or that is a plan for differentiation. So here we go. Information on the gaps for scaffolding and differentiation, vertical mapping for creating support and foundation of success. If you've been around me more than a day or two, you know, Achieve the Core is my place to go. The coherence map, and you know, it's just like this. You go to the coherence map, you choose the grade level, then you choose where you're going. So we've been talking, I just mentioned fractions, so let's go here. This first standard, all right, is ratio and proportion. It's about unit rates. Kids get confused about unit rates. Where's that broken down? It could be they need some scaffolding. Just break down that skill a little bit, or maybe some differentiation. And for differentiation, we say, you know, what happened before this that caused the student to not be successful? So let's look before. And our sixth grade teachers know, or you may be 6 and 7, you know, that skill is taught in sixth grade with different types of numbers, just like we said, differentiation, that's a way. We also know, if you're also a fifth grade teacher or you talk to them a lot, fractions come from fourth and fifth grade. So it could be the skill of fraction itself that I can't use a ratio, that I can't do an equivalent proportion. Because what are equivalent proportions? Well, they're nothing more than equivalent fractions, right? So no guesswork. Absolutely. Please don't guess. And can we differentiate? I get all this. Look at this. We can extend the learning. Oh, even on grade level? Absolutely. All right. So differentiation goes both ways. And it drives me crazy because it's a horizontal screen talking about vertical alignment. So all right. So there you are. So, and then if you've never used the coherence map like that, you just used it, and I have used it like this too. I want to go find a cool problem to a certain standard. Illustrative mathematics is embedded in the coherence map and Achieve the Core, but you haven't done anything besides that. Click the next link. It is in your handout. It's a how-to. And when it wakes up, it's going to tell, see there, it's going to tell you exactly about coherence maps. Actually, students can create them too. It tells you how to use it. And this is just what I went through with you, showing you how the coherence map is a map of, it's actually a map of vertical alignment as much as it is alignment to your grade. It helps you differentiate each skill that you're teaching. Want to make, I know you know this, but if you haven't heard it in a while, it's all about diagnostic planning and instruction. Remember, the standards aren't implemented until we plan for instruction. They are still not implemented until we deliver that instruction and it joins hands with learning. Very, very important. So I wanted to say the next thing with our instructional design is, well, how do I have time for differentiation and scaffolding and and problem solving? And okay. I actually, it's almost been 2 years since we did a pilot, and we did pilots in public schools and the diocese schools. And I want to show you one training that we did with the teachers that were piloting in these schools. Absolutely the coolest thing ever. So I chose the 7th grade to show you. And first I want to talk to you about the workstations themselves, how they evolved. We looked at next generation learning standards and say, okay, how can we do this? How can we get problem solving, discourse, differentiation, high engagement, and motivation? Like low expectations, right? So, you know, when I was still in the classroom, I did learning centers a lot. So I don't want to use that term not interchangeably, but to me, they mean different. Learning centers mean I planned for different things and kids transferred from one place to the other, and it was all fun. And it was really good. It was an extension of learning and practice. Workstations we created and designed to meet all those needs I just mentioned. The discourse and the problem solving, differentiation and fluency, blah, blah, blah. Here we go. So what did we put together, analyze, and see how will it launch? Well, one, problem solving is the heart. Didn't we say problem solving is the heart of mathematics? You are not a mathematician until you can problem solve. You might have fast facts. My mom wanted me to be faster than lightning when I was in 4th grade. And believe me, because I did want to get in trouble, I was. So I thank her for that. But problem solving puts it all together. We apply what we know, we read the problem, we understand, we interpret, we write the equation, all that stuff. So problem solving is the heart. We put it as the #1 workstation because it is going to run the show. It chooses the standard. It decides what skills we don't have. It decides what simulations and engagement are going to happen based on that standard. So problem solving is the first thing you choose. From that, then we choose an engaging standard that looks at the skills that I need inside that problem. Remember when we framed it and we looked at the numbers and the units? We started making decisions about skills at that time. So engagement takes one of those skills and makes me practice it. Fluency. Fluency is a showstopper if we don't have it. So fluency is a place to start differentiation. Eureka is a great place. They have those fluency sheets and those fluency exercises and practice already built in. Not memorization, but automation. So, and that's another workshop, and we'll talk. We need to talk, those two differences we can, but not today. So, you want kids to be fluent, automated, not just memorized. I don't have to start with A to get to Z. I don't have to start with 3 times 2 to get to 3 times 9. Then I become automated with that. So that is a place where differentiation can occur. And each group that cycles through the workstations could have a different fluency practice, all right? Could also have a different type of engagement. But let's start with fluency for differentiation. And then simulations and Desmos. So great practice problem solving and what? Motivation. All right, so check. We've met them all. Now here's what it looked like. So 7th grade student-centered learning, and this is your teachers. I loved it, and they were so excited, and they were so much fun to work with, and they have taken this to their classroom. It looks incredible, absolutely. And so here they're looking at, we chose 7, RP, and EE, ratio, proportion, equation, expression, and they are all solving, comparing, and oh, look at this. This was a big justification because they had the right answer. They solved in different ways. All right, so then we start to say, what is the most efficient way to solve? And how can you justify that? Then we go on. Okay, so then we have, I have to read this to you. So this is, it was just too simplistic. Multiply each dice, then multiply the 2 products. That's too simplistic. So what is 20% of that? Well, now let's push them some, all right? So then is there a pattern doing it 10 times? All right, so this was teachers doing that. They took that to the classroom and had so much fun with that. We actually had to differentiate that some because product times a product, some kids stopped there, and then 20% of that, some kids had to stop there, then do it 2 to 10 times. Wow, is that so cool? Yeah, we milked that one a lot, got some incredible things with that. And then the simulation actually is on unit rates and is on PhET. And if you hadn't used that, you absolutely need to. This one goes straight to PhET. PhET is simulated. Okay, I think, we went to the prediction one. All right, but it is a simulated unit rate. Well, this one is. And the simulation on unit rates works like this. The SPET itself, I don't mean to stutter, I just need to show you the whole thing. All right, so I'm going to go over here and I'm going to get FET real quickly to show you the whole website. It actually started as science. It actually started as physics. That's the PH. Then it extended to high school mathematics with STEM. During COVID, it went down to elementary and middle school. So I can click middle school and you have simulations here. And so while I'm here, I will go ahead and tell you a little bit about FET. So you know you have this resource. Some of my favorite ones, absolute favorite, teaching integers. So I have a girl that swims, and I have a flying fish, and I have like a porpoise thing. All right, so look at this. It comes up. I've got -29 is less than 0. So I'm writing inequalities as well as graphing, as well as using a picture of sea level. So a real life scenario. And so -20 is below sea level. Let's see the girl. So, oh, look at this. So are they all below sea level? Well, which one happens to the girl when I bring her up? Cool, right? Yeah, so, and then I have the inequality. So you get a lot of conversations right here. -29 is less than -9. How is 29 less than 9? And look at it. Oh, I'm going deeper. So this increases. Well, I got to bring down this porpoise as he goes deeper. Oh, he can fly too. All right. So enough of that. And then you go on and we can talk money. Money is fun if you have it, right? It's a pain. So we're growing. And guess what happens when you don't have it? Oh, big fat red pig. All right. So you get this. And you also have the inequality. Well, what I really like, and it's actual. So I'm going to set us in May. There you go. And I'm going to take one thermometer up here. I'm going to take one thermometer up here close to New York. Oh, well, where I live, it's not 73 degrees, but maybe it was today. I don't know. Let's put one in South Africa because the seasons are flipped from us, right? So we are nearing spring, nearing summer, they're nearing winter. And let's go down to the Arctic Circle. Look, isn't that the coolest thing ever? You can change the months, you can change the locations. It's so realistic. We could even write a problem-solving scenario, right? Anyway, I wanted to show you the power of simulations and then also Desmos. We did not use Desmos for this, but if you have not been there, I did put it on your handout. And so Desmos, here we go. It used to just be, when I first started, online calculator. And now it is activities. It is growing into curriculum. But if I said I want to see Desmos, let's see slope. Let's do a slope activity. How about that? And all I did was Google it, right? All right, so I'm going to go here. And if I have signed in, let's see if I'm signed in. It looks ghosted out to me. Nope, I'm signed in. Then I can create, and you see I created it earlier, create an assignment, create a scenario with it. So first I have to see, do I like this? Nope, I like it. All right, so I look at the problems and oh, yeah, I like this. It talks about rise over run. It gives you teacher moves down here at the bottom. Absolutely wonderful. Okay, yeah, I like this. I'm going to assign it to the kids. We're going to do it. So then when you are signed in your free account, you can click the assign button, assign it to all your classes or a single session code. And when you do that, and I'll just go, you get this link right here because I did that today. you go to dashboard and it tells the kids how to sign in. There. You put that on the screen, you put the link in the Google Classroom, and then when the kids sign in, it says I have no students at this time. It starts to show them signing in right here. And then you can watch their success. And then you notice that like kids are having a hard time with number 6. So I'm going to go to the student view, and you can use this as a teaching screen. So we talk about drag point B, so the given line of the slope is -1/4. So what do I do with this? And so, okay, you know, I'd have to drag, well, we know that's not negative. And so, but I want it -1/4. So you just do that, whatever. All right. So Desmos, just Google it. I know that Desmos is going through some transition. But I expect it to still be used for free. Also, Desmos is part of Envision, SVOS, and also a part of a couple of other curriculum. All right, so there was that. Now we're back to thinking about our workstations and winding this piece up on workstations. You say, okay, they don't remember all the work they did? Do we just clap? No, we got to get feedback, right? Now, if we were doing a workshop on workstations, we would talk about monitoring growth and things like that. And that's of the other 3 workstations. I'm going to focus on problem solving. Problem solving is assessed through the 4 strands of proficiency. Now, not a new idea. Actually, in the early 90s, there were 5 strands of proficiency looking at mathematics. But now with the turn toward problem solving, actually 2 were under the understand category, and those kind of got lumped together with the birth of Common Core. So this rubric actually was created by me and a bunch of teachers with a grant in the DOE. And we built it around 4 strands of proficiency. We used it with about 1,000 kids and a whole bunch of schools in a big, giant district. It got tweaked and evolved and tweaked and evolved until it matches exactly what we were trying to teach with next generation learning standards. All right, so here we go. Let me tell you, to read it across the top with the columns, you see I can score different levels: beginning, developing, mastery, and exceeds. All right, so mastery is where I go. That's what I'm shooting for. In fact, when I teach this to kids, and I do teach this to students, yes, they grade their own. I also assess, but this helps them analyze their own work. It's that critical thinking piece again, and they can do it with their work. So this is mastery. Now, what are those 4 strands of proficiency? Understand. And I want you to notice we have student talk here. Teachers put that in. All right. So teachers put that in, and it is student talk and teachers look for. So student talk is show what I know about the problem coming from the 3 reads, and also teacher look fors. Students show understanding of the problem and work independently. So you see this in all of them. So it helps the student know what to do. It also helps the teacher what to look for, and then vice versa. The student knows what teacher, you have this, isn't this great? It's very important. It helps the level of expectation. So if I know what's happening over here in the understanding from the 3 reads, then what does mastery look like? Showing understanding with operation, types of numbers, and relating to the problem. Oh, I understand the problem. I pulled out the numbers. I have my units, and whatever I'm doing, I'm demonstrating understanding. And so what does it not look like? You see where this is going. It is a very important way for the way our brain should do for critical analysis thinking. So what is not getting there? I don't show understanding. I'm uncertain about the operation. Okay, I put down some numbers. I don't connect it to the problem. Remember, It's 3 numbers I think I should add. You see how this is developed? Okay. Then fluency with accuracy, it is what it is. Model or represent the problem with accurate answer. Okay, so I have the accurate answer, but it's more than that. I represent maybe with an equation. I represent with a model, a tape diagram or whatever, a graph, and it is accurate. Can I have one without the other? Usually these are coupled, but you can come down here and not be able to do it, all right? So let's look at that. So understanding, fluency with accuracy. Problem-solving strategies. I show them a strategy and the solution. What is mastery? Connect a strategy to solve the problem accurately. So I did this and I have a strategy. I can show. All right, so that's more that how that's coupled together. Communication. This was hard for teachers to wrap their heads around. How do we measure communication if we don't stand there and listen? Well, in kinder and first grade, we are going to do more of interview type. But by the time they get to us, here's what they can do. They can connect to the strategy, solution, units, and answers the question that's in the problem. Back to the 3 rates. All right, so students need feedback. Oh yeah, what's the blue for? Well, after everybody gets to go green, let's say go blue. Let's exceed. Or we have, very wide abilities in a classroom. We need to recognize these kids that do more. They need to know they're doing more. If I'm always here, don't they know when they want to know how to do more? I'm sorry, my dog is whining. Anyway, so that's where the exceeds are. So let's do that. So in closure, and I know I've had to redo part of this this video, and so it's not going to go the whole hour and a half because I didn't stop in the last part because I have no students now. I'm just had to redo it, kind of shut on me. We are going to talk about closure, building retention, and going with the beginning, middle, and end of mathematics. So what does that look like? I am refreshed in this, but if I'm going to really build retention, I have to close the lesson, close the problem. It's very important. We spent all this time planning the instruction, aligning with the standards, making sure that we have great instructional, rigorous design, making sure we differentiate and scaffold so all kids will learn and progress. What if you spent all that time developing a document? You don't name it, you don't file it, you close your computer. Where is it? That's what happens with our average kids and our struggling learners if we don't put closure. It can even happen with our bright learners because they're thinking about so much. So we frame a closure. What are the big ideas today? What is the takeaway today? Right? 3, 2, 1. 3 things you learned, 2 things you already knew, 1 question you still have. Close the lesson. What it does is file, save as, put it in a safe place. So what? You can retrieve it. That's the neocortex at work. File, save as. What did we talk about yesterday? Retrieve it. Guys, it's that important. It's as important as choosing the standard that's a mastery standard or a priority standard. We want to teach it to mastery. It's that important. If you want kids to remember, we have to put in strategies so they will remember. Closure is a big one. It's more than a big idea. It is almost the idea, talking to the neocortex and saying, I'm going to put that in a safe place. I'm going to file it in a certain file, not chaos back there. Have you ever seen Donald in Mathmagic Land? If you hadn't Googled it, it's an old 50s video. It's great, but it shows Donald and his head is going like this. His neocortex is not organized. So we want it organized. File, save as, put there, retrieve it. Enough, right? All right. So the beginning, what did our lesson look like? We started with a math talk. We started them thinking immediately how, not procedurally, but discrepantly. All right. We showed them a not example, and they had to use critical thinking and analysis to find it. The middle of our lesson, it could be very conceptual, a mini lesson, workstations. It was differentiated. It was motivating. The heart of everything we did was problem solving. And we have a way of tackling it, that the 3 Reach protocol, and getting them to understand. Feedback with the 4 proficiencies, as 4 strands of proficiency. So we end every day and we start every day, and the middle of our day is mathematics. So what are some big takeaways? You can put that in the chat, and they did earlier, and I'm refixing this. But thank you so much for everything that you have done, and really have kids learn mathematics and be problem solvers. Then they will be mathematicians. And I know you did the attendance because I downloaded it, and the reflection goes to the diocese. And thank you again. Pam Warwick, Generation Ready.